any longer for your classmates, they can show up if they're still on their way. So today is the 6th. One thing that I want to cover with you guys, this from now on, because especially on Fridays, with classes being boom, 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 me like closing a smart file and opening a new one, it is just killing too much time. So I'm from now on doing one file with everybody's guided notes, like, or everyone's like captured notes from the day. So they have a mastery assessment, so they're not going to have notes, but there's math too, and then I go back one more page. So your notes, and if I show you this, your notes today will be the first thing because you're my first thing, but normally you'll be the second thing. So if you go to look at the PDF, which I haven't always been uploading the notes, but I will now because it's a little bit easier. If you go into Schoology, which actually I'm gonna ... Yeah, you got my password.
I did.
Beautiful.
Wow.
So like yesterday, right? What lesson were we in yesterday? 8.5, right? We got into, that's really what the day was. So if you go to 8.5, already from yesterday, there is not. But there will be a PDF of all the notes. Maybe I put it in the 8.4. Thank you. You have the notes from yesterday already, right?
Yeah.
So right here, notice this says all class notes. I guess I put it in 8.4 because we had been working in 8.4, but I'll copy it to 8.5 probably. So when you open this PDF, it's every single class. So the first set will be Accelerated 7, and then you can like just scroll on through those. So now this will say Accelerated 7, so you'll be aware that it's Accelerated 7, so you can move on through those, and then we get to our Math 7 stuff, and then if you scroll on through, if you care, you can see what we do in high school, which is really crazy complicated binomial work right now. Not scary, you just haven't learned it yet. So, just so you're aware, this file is going to be one big continuous file now. So, yesterday we ended talking about rental trucks, and today we're going to start talking about the temperature outside. So, when we woke up this morning, it was 5 degrees outside.
Yeah.
But 5 degrees what? Fahrenheit, right? Because we're in America and we're dumb and we decide to go with a scale that doesn't make any sense.
Thank you, America.
Let me defend myself. I like that you got upset by that because, you know, I shouldn't call us all dumb. But this doesn't make any sense. Because, so let's say it's 5 degrees right now. Let's go ahead and make a little mark that it is 5 degrees, which is really close to 0. So actually, I'll put it up a little bit because we can have temperatures below 0. But, so somewhere, what is the mark in the Fahrenheit temperature scale where water freezes? Anybody? 32, right?
Yes.
So, let's make a mark somewhere that is our 32 degrees freezing. But then, yeah, so draw this on your paper. If you haven't drawn like a little thermometer, you don't have to have all the lines that I have. What's the freezing temperature in Celsius? 0. That seems to make sense. 0 is when water stops moving. It is totally frozen. It is 0. So on the same line where you have your 32 degrees Fahrenheit, put your 0 degrees Celsius, but put it on the other side of the thermometer. Because a lot of thermometers are rated in both Fahrenheit and Celsius, depending on which side you look at. Now, what's boiling in Fahrenheit? When does water boil and turn into steam? Yeah. Yeah, pretty.
Is it 2,000?
2,000?
No, sorry. 250.
Close. Leah? 212. So make a mark somewhere that is 212 degrees. So wait, in between these two temperatures, between boiling and freezing, is a distance of 180 degrees. But what's boiling for Celsius? Abby? It's the first time I've done that. I apologize so badly. I'm sorry. Look, it was worse for me because when my teachers called me Abby, my older sister's Abby, I'm like, hello, I'm a boy. So, sorry, Ellie, you're not your sister. Isn't it what? It is 100. So in the Celsius scale, 100 is boiling. So like 0, everything is stopped. 100, everything turns to steam. I mean, if we're talking about water. So the distance between here is only 100 degrees. If it's below freezing, it's below 0. If it's above freezing, it's above 0. If it's below boiling, it's below 100. So this is why I say that we Americans using Fahrenheit are kind of dumb, because we've made our life more complicated. When I ask you what's boiling and you're like, 2000, 24, who knows? Yeah, who made up this number? What the crap? I feel like some dude just put some chemical in a glass thing and was like, all right, here's a mark. I'm going to call that 32 degrees. And then it got really, really hot, and he's like, here's another mark. I'll call that 100 degrees. And here's another mark. I'll call that 150. And made up some scale, and now we've got Fahrenheit. The rest of the world uses Celsius. So this, hang on. So this creates problems for us, right? So when we do scientific experiments, a lot of times we work in Celsius. When we go outside and ask what's the temperature, when you pull up your weather app or look at your car, it's probably giving you Fahrenheit. So we have a conversion formula that we use so that we can take our Fahrenheit temperature and make it Celsius, or take our Celsius temperature and make it Fahrenheit, depending on what you're trying to do. So right here, this would be if we had Fahrenheit, what is the Celsius? Because we would be solving for C. We want to build an equation to solve for Fahrenheit when we know the Celsius. So you might need to get a Post-it, especially if you've already written over here. But we want to start by writing this Celsius equation. And we actually, when you write this, hold up. When you write this, leave space before your 5/9. So after your equal sign, leave some space before you write your 5/9. F minus 32. Carolyn, did you have something?
I wanted to say I had a friend who was in England, and this summer I said it was like 90 degrees outside. She started flipping out.
What? Are your trees on fire? Like, so 90 degrees Celsius, and we can actually, once we get our formula, we can play with this. But if her friend thought that it was 90 degrees Celsius, that's like almost 200 degrees Fahrenheit. Like, it can't physically get that hot. Ella? You're not allowed to use these.
Don't eat them. Okay.
Wait, this is on video.
Oh.
So, just so you guys are aware, the camera goes to like here and like here. That's all it can see. It can't see you guys. It can't like. So, if we want to get Fahrenheit by itself, if I was you, I would highlight or something that we're solving for F. What's the first thing that I want to get rid of here? Leah, if you were approaching this problem, what do you think you would try to get rid of first? Yeah, the 5/9, because I could distribute into the parentheses, but that's really annoying, especially since this is a fraction. So Leah, how could I destroy that 5/9? But that's going to be 0.5 repeating forever, and that would be annoying. Josh?
Divide the 5 by 5 and then 9 by 9.
But instead of dividing a fraction by a fraction, instead of dividing by fractions, Leah, do you know? But instead of, so yes, but instead of doing that, we choose to, because we don't want to divide by fractions, that's really complicated. How many halves does it take to make a whole? Because if I want to cancel out to 1, Ellie? Multiply by its reciprocal. If I was you, I would write this in a different color, or I would highlight it, that it's something special happening, because we have to do that, and then if I do it on the right side, I have to do it on the left side. So I now have 9/5 C equal to just what was in the parentheses, so now it's just F minus 32. Sebastian, what would I do now to get my F by itself?
Okay, so I would say also you need to add the 32.
We got to add 32 to undo the subtraction. We add 32 to both sides, and that then gives me just F on my right-hand side equals 9/5 C plus 32. So right here, where we see our new formula is, that's going to be 9/5 times the Celsius temperature, then plus 32. That 9/5 relationship, hang on to it for just a second. That 9/5 relationship anyone figure out where 9/5 kind of comes from?
Wait a second.
Brady?
Wait, in this problem?
Like, so we use 9/5 or 5/9, depending on what direction we're going. But why?
Because, if we just multiplied it, so if it was 5/9 times 5/9, that would just make it not what you wanted. So you have to reverse it.
You're kind
I think this is just.
Wait. Oh, so it would equal to 1 because 9 times 5
Not
equals.
quite. So you're still stuck in like solving the equation. I'm not talking about solving the equation anymore. I'm talking about why is there this relationship of 5/9 or the relationship of 9/5 that we just talked about. So this was 9/5 C plus 32. Josh?
I'm pretty sure this isn't right, but the distance between the boiling and then divided by 20.
What if you do
Oh, that was right.
180 so degrees Fahrenheit per degrees Celsius? That would be 180 over 100. What do you get when you do that division? 9/5. That's where this conversion, that coefficient, that 9/5, that's where that comes from. Where do you think the 5/9 comes from?
The 5 is from the 100.
Flip this over.
Oh,
100 divided by 180, that's 5/9. The distance between freezing and boiling is where that fraction comes from. And guys, I'm going to tell you, nobody ever told me that. I went through my entire childhood, up into college, just thinking that was some magic number. Like somewhere, some really smart person figured this. No, they're not really smart. It's just that our distance is different than their distance. And when I compare them, I get this awkward fraction. The plus or minus 32 that happens is because of this. At 0 Celsius, I have to make 32 Fahrenheit. So I gotta add the 32. At 32 Fahrenheit, I gotta make 0 Celsius. So I take away the 32. Katie?
Where did you learn that then?
I finally figured it out.
Oh,
I was teaching this a couple years ago, and a student asked me, and that's what's really funny. Sometimes teachers, we learn with you. We're all constantly learning. So a student asked me, why do we use 9/5? And actually, I think they asked about the 5/9 because it's a repeating decimal. I'm like, why would we use a repeating decimal? That's really bad. That's kind of ugly, right? It's hard to work with. And we kind of stepped back and looked at it, and we really set up that whole distance between freezing, boiling, and I was discussing that just as look at how ridiculous this is. And if you think about the numbers for a second,
And then they put it there.
how 10 relates to 18, I mean, if you take the zeros off, or how 18 relates to 10,
Yeah, that's what I did.
yeah, cut them both in half. There's your 9 and your 5, or your 5 and your 9. That's where it derives from. And nobody ever specifically taught me that, or if they did, I totally missed out on them teaching it to me. But yeah, so and that's why I do what I do. That's why I teach math. This is beautiful. Although I think it's absurd that we use Fahrenheit, that mathematical formula that lets me switch one to the other, it's awesome. So, if Carolyn, you were going to call your friend in England and talk about this morning and how flippin' cold it is outside, we know the temperature in what degrees? Fahrenheit, right? We know Fahrenheit was 5. So we have, you might need to post it because we're doing a lot with this problem. We have 5 degrees Fahrenheit. I guess I could have just said like temp. So we would use this formula and say my degrees Celsius will be 5/9 times the 5 minus 32, all in parentheses. So the first thing we would have to do, follow the order of operations, is solve in my parentheses. So this would become C equals 5/9 times negative 27. And actually the 9 and the 27 are going to work out really nice with each other, because if I do this, these can cross-reduce with each other, and this can actually become negative 3, and this can cancel out to 1. You wouldn't have to do that, but again, it makes my life easier. So if you looked at your weather app in Celsius, this morning was negative 15 degrees.
Does it always work that way that you could multiply by 3?
No, that's because the 9 and the 27
Oh,
are
okay.
both factors of
Okay.
9, or both have a
I was
9
like,
as a
damn it,
factor.
I thought I found a cheat sheet
No.
for the math. Just
So
multiply
you could tell your friend, hey, it's negative 15. And actually, here, when it goes negative here, it's even more negative in the Celsius, because think about how far down that gets. So it gets pretty crazy. And I don't think it gets as cold in England as it does here. I'm not certain.
No, because they aren't.
They're at
Oh,
different,
that's crazy.
different longitude, right? Yeah.
Is that it? We're done with this problem?
Yeah, we're going to the back now. We're finally going to the back. Sorry if you have like 9 Post-its on your paper now.
No, I think it's
I
fine
don't
because you
think
always
it's
get
supposed to
we
be
have
that
Fahrenheit instead of Celsius.
Well, that's because we're the only ones.
But I like to freak out at
Literally,
the temperature.
we're the only ones in the whole
I'm
world.
pretty sure we're the only country that uses Fahrenheit.
Yeah.
I could be wrong.
What about Canada?
They probably use Celsius. They use the metric system.
Yeah, Canada's better than us.
Canada is better.
Why we're the 7th smartest country?
Okay.
You just switch.
I'm
Not first.
about to blow your mind.
That's
So, how fast, if you were to estimate miles per hour, how fast do you think space shuttles go? What do you think?
2,500 miles per hour.
2,500.
Way better.
Anyone? Any other guesses?
3,550 miles per hour.
3,550.
806 million miles.
I don't think that's a good
That's in the 463 days.
Oh, can I do something?
So we're going to do some math here in a second. Reagan, what do you think about miles per hour? How many? Like 1,000,000 miles per hour? That'd be really, really fast.
Yeah, yeah.
I mean, that's fine, but that's really, really fast. Ellie? 1,000 miles per hour? Let's do some math. Let's figure this out. Stop. Put it down. I feel like I'm talking to one of my dogs. Drop it. Highlight the important stuff. Is the date important?
No.
No, not for math.
Except May 4th.
If you go over there, Pettigrew might tell you it's important, but yeah, and it was May the 4th. So May the 4th be with you.
May the 4th be oh my God.
Oh my god.
So the time, the amount of days, and the distance, the amount of miles, that's what's important. I need you guys at the top of your paper, above, and I scrolled too low, at the very top above where it says like the 8.5, I need you guys to rewrite our dirt formula, but we need to write what it actually represents. What do those values in the dirt formula stand for? So like, here's our dirt formula, but what does that stand for, Leah? Distance,
Oh, we
yes please, equals rate times time. So this spacecraft, Magellan, this is real, traveled for 463 days, a little over a year. Imagine being in space for a little over a year. And it went a total, because it went to Venus, it went a total of 806 million miles. So when we set this up, that 806 million miles, that's my distance. This 463 days, that's my time, right? Because that's how long it took. So when we set this up, D equals R times T, I know that my D, well, you can't just write 806 though. It's 806 million, so you got to tack on 6 zeros. equals, we don't know our rate, but we do know our 463 days. Now, if I wanted to get the R here by itself, the rate value, Ryan, what is happening to the R right now? Like, what is the 463 trying to do? It's trying to multiply, right? How do I stop it from multiplying? What's the opposite of multiplication? Division. So we stop it by dividing. So we're going to divide on both sides by 463, and that's going to give us our rate or our speed, but that's going to be in miles per day. So this, when we get this answer, is going to be miles per day. So Reagan, you got it?
Oh, I thought we were supposed to do MP.
Hold on, we're getting there.
Isn't it 100 or 1,740,000? Yeah, 40,800.
So this, please label, is miles per day.
I have the average one.
So guys, in one day, they went almost 2 million miles.
Jeez.
You ever driven like all day on a road trip?
Yes.
You drive all day on a road trip. Like if you drive like 12 hours, you'll maybe go 1,000 miles. If you're going pretty fast and you drove all day long. 1,000. They went 1.7 million. Now let's figure out how fast they were going miles per hour. So hold up. Set this up as 1,740,000, and you can use the B space. This is the question for B. So you can use this. But that's miles over 1 day. To convert this, we're going to do more of that stoichiometry. We got to use that conversion factor. What conversion factor am I going to use, Brady? Not actually here. We want to convert, so we always multiply to convert. I mean, division is multiplication, technically, really, but Josh?
We would multiply by 24.
Multiply by 24?
No, divide by 24.
Divide by 24. But here's why I said that we're actually multiplying. Because we have one, and please write all this work, we have 1 day is equal to 24 hours. And guys, we did a little bit of this earlier in the year. We set this up so that when I have days on top and days on bottom, what happens to my label of days? It goes bye-bye, disappears. So what I'm going to end up with is the miles per hour, which is what I want. So we really take our 1,740,000, sorry, 820. I forgot the 820. Please be more accurate than I was. And divide that by 24, we get a result. Josh?
Let me try to say this. 11,112. Can I tell you how I did it?
Can anyone verify that? Hold on real quick. Did anyone else do the
Say
division by
verify or verify?
verify? I just want to make sure it's right.
Is verify even?
Yeah.
To check, to
I
make
know, but
certain.
people say verify and verify are like the same thing.
What? Verify, did you just say?
That's not
Yeah.
hard.
Terrified?
You mean clarify?
So, wait, Josh.
What?
40. I think you did something wrong, bud.
Okay, I'll tell you what I did, and then maybe you can tell me what I did wrong. Would that work?
I think you maybe divided too many times. So if you wrote this down, please erase it. It is actually, I thought it looked wrong.
Yeah.
72,534 miles per hour. So all you guys that guessed 2,000, 3,000,
You were way off.
they're miles per hour if they were driving on the highway. 72,000
How do you do that?
miles per hour. So guys, take the speed that your parents probably drive on the highway. Yeah, I bit my tongue.
Yeah.
Take the speed that your parents drive on the highway. 72 miles. Cover that up. And that's how fast your parents go on the highway, probably. About 72 miles. Take the speed of your car and multiply it. Can we move on? Or are we so immature that we get stuck there? Because that's what it is. The immaturity gets you stuck there where you can't move on and you keep laughing about the same thing.
I wasn't laughing at that. I was laughing about something easy.
But you guys were still stuck from that same, like, you lost focus from that little thing. So take the speed that your parents drive, multiply it by 10, then multiply by 10 again, then multiply by 10 again, and that's how fast the space shuttle is. They're 1,000 times faster than your car on the highway. That's insane, guys. You're like stuck to your seat at that speed.
Stuck in your seat, you mean?
Well, it's a good thing that there's no police out in space. So,
Oh, like Jetsons.
If there were space police,
so try to figure out.
There's no sound in space. They wouldn't know when to pull you over.
Try to figure out the feet. Or sorry, try to figure out the distance. What are we actually doing? Solve the distance. Yeah. We're solving the distance formula. We know 700 feet per minute. So that's our rate, right? We want to solve it for time, though. So hold on. We're not even using the 704 feet yet. Look at what the question asks us. Solve it for time. Get the t by itself. So when we set up d equals r times t, well, why is t not by itself right now? What's with it? Zion, what's with the t? What's with the time? Of what? Well, what's with the t? What's multiplying with the t? The r, right? So how do we get rid of it? By. So I agree, I'm going to divide, but what is it that we divide by? If we want the t to stay, we're getting rid of the r, that's what we divide by. So this leads me to, these cancel each other out, and I get that the time will equal the distance traveled divided by the rate you were traveling at. So guys, that makes sense. If you have 1,000 miles to travel and you drive at 50 miles an hour, you would do 1,000 divided by 50 and get how many hours it's going to take you. Make a note. This time is going to be whatever unit your rate was given in. So here, our time is going to end up in minutes. If we did time for like the spacecraft things, whatever, it might be days, it might be hours, it's whatever your rate has been given. So now it says, find the time it will take for an orca to swim 26,400 feet. So we know, what is the 704 feet per minute? Is that distance, rate, or time? Casey? This is distance, 704 feet per minute.
Oh, no. I
Yeah,
forgot
this
about
is
that.
distance. Sorry, you were probably still down here. But what is the feet per minute? That gives me a
Right.
rate. So that's distance. This is rate. So set up your formula. T will equal that distance divided by, and please label, it's the distance of feet, divided by the rate, 704 feet per minute. This will give us an answer in minutes. Ellie, you got it? What is it? 37.5. So guys, 26,400 feet is 5 miles. This is 5 miles. And an orca can swim that in a little over a half hour.
That's not that far.
Can you swim
So-
that far? No.
So that's approximately like 8-ish miles per hour. So like the speed, if you were at a fast run, that's about fast run speed. Like, well, depending on how fast you run, that'd be like my fast run. Some of you guys probably run faster than that, but crap. Well, that did not capture. My apologies. My board is not totally on its orientation. So we want to solve for B. And it says write a baking problem that you could model with this equation. So let's think about what variable b could represent. And if you bake, well, it would have to be some quantity, right? It's a variable, so it's representing some quantity. Solomon?
Batch.
Yeah, batches. So maybe b is how many batches we're going to make. So let's say b is the batches made.
Banana bread.
Sure. Of banana bread.
Banana cookies.
That's
Oh,
good banana bread.
that don't sound good.
I've never eaten banana bread before.
Okay, let's try it.
So-
Bananas, there's no-
Sorry, my C looks like an R. So we'd be solving for number of batches, and that 2.5 would represent something, and the 3 3/4 would represent something. But man, if we start with 2.5 B, I'm going to make it capital, equals 3 3/4. Shoot. My coefficient is a mixed number. What's easier to work with than a mixed number? Ella? An improper fraction, or sometimes a decimal, but because we don't want to use calculators here, let's use improper fractions. So convert your 2.5 to an improper. 2 times 2. 4, add the 1. We get 5 halves B equals, convert this to improper as well. 3 times 4
12,
plus the 3,
15.
15 fourths. How, Olivia, can we get rid of that 5 halves in front of the B? But instead of dividing a fraction by its, yeah, we gotta multiply by its reciprocal.
Wouldn't it be 2.5?
Because that's 2.5. So think about pizzas. If you have 2 whole pizzas and a half,
Oh, so
how many halves do you have? A half, 2 more halves, 2 more halves. I have 5 halves total.
But there's 5 over 2.
That's 5 halves.
Would it be 5 halves though? Because there's only 2.
How many halves are in each whole?
Never mind.
How many halves are in each whole?
Halves 2.
2, right? How many halves would be in 2 wholes?
4.
4.
But then there's another.
1 more half, we now have 5 halves.
Yeah, but 2 are whole.
Josh, I'm going to move on because I'm hoping you actually understand what we're doing and you're just being goofy.
I think.
If you don't, we need to talk more later.
Okay.
Because if you can't figure out how 2.5 pizzas gives you 1 half, 1 half, 1 half, 1 half, and 1 more half gives you 5 halves total, we need to talk later. If we can't make that connection.
Okay, I was just confused. But anyway.
Good? Because, I mean, we could draw this out too. Think about if I have 2.5, how many halves do we have? 5. So, what haven't I done yet up here that I need to do?
You need to multiply it on the.
I gotta do it
Oh,
on the other side. And actually, there's a ton of cross reduction that can happen here, but I'm not going to worry about that. If you want to cross reduce, you should. I'm going to show how it is more work to not cross reduce. So this would become 30 over 20, and I would then have to reduce now, which would become 3 over 2, or as a decimal, that's 1.5. So we've made, supposedly, 1.5 batches.
Where did we get the 30 over?
15 times 2,
Oh, we're on that side.
4 times 5.
Okay.
So really, if you want your equals to line up, I'll shift all this over. Any other questions? You do not necessarily have to write a problem. Solve for R in the got it. If you want to write a problem, if you're creative, you can go ahead and write a problem involving when we would solve R. What do we do to the half to get rid of it? How do we make it a whole? By the way, we're going to get to probability later this year, but because I'm going to take this down this weekend, Mrs. Goldring took it on herself to be my Secret Santa. This card says 4 out of 5 people get money in their Christmas card. It says Merry Christmas, number 5.
Oh,
Because there was nothing in it. She thought I would like that because it's pretty darn funny.
Does it say Merry Christmas number 5 on the card?
Yeah, like in it. So 4 out of 5 people, right? So here's 5 people. You 4 and me. You 4 apparently all got money and I didn't. Is what that
I got
card says.
$75
oh,
for
that's
Christmas.
hilarious.
So if I have half R equal what was 1 2/3 as an improper?
Oh,
5/3. Then Brandon, what do I do to get the R by itself? Yeah, multiply by its reciprocal, which in this case is 2/1 times 2/1. There's no no cross reducing that we can do there, so this becomes 10 thirds. So whatever that represents, our R would come out to be 10 thirds. And that's why I didn't tell you to make this a story problem, because that'd be kind of weird. That as a decimal would be 3.3 forever. So you would have made like 3 1/3 of something. Now in baking and cooking, we do use thirds, like a 1/3 cup. That gets used a decent amount, but we never talk about decimals. They would say a 1/3 cup. They would talk about the fraction. Okay?
Or if you can do another full batch, you can do a half batch or a third batch.
Yep. You can do different sizes of batches. Or I could like do a double or a triple batch, like you can make smaller amounts or bigger amounts. But that gets dangerous with baking, apparently. Because it doesn't always, like, when things are rising and, like, there's yeast and flour and stuff. So I've been told, now I don't bake, but I've been told that it's dangerous when you start to, like, multiply up or divide down. I've been told that gets hairy.
It depends how well you know the recipe.
Yeah, see, there you go. So I'm not a great baker. I can cook up a storm, like dinner and what, but baking, I'm not as good at. So, because I got my start cooking on a fire. You don't bake on a fire anymore.
Yeah.
Oh, I thought you said
Through Boy Scouts. That's when I first started cooking ever.
I had a nice sandwich.
That's
Yeah, they don't have a baking merit badge. They have a cooking merit badge. We have, 5 minutes left? Today's Friday.
3 minutes.
So,
Simon says.
there's not really time to actually... So if you want to see what's going to be on your mastery next week, let's actually just do this.
we have a review.
We haven't done a review game in a while.
I know, we don't have time. If we had gotten done with the lesson faster, but this is what I talk about, was when we have to stop and, I have to wait for people to get quiet, or I have to wait. Hey, Brady, you the person who just complained, I'm giving an explanation for what you just said. We were going to play a review game today, right when we got done with the lesson, but throughout this chapter, we've had to wait for people to show up to class, we've had to wait for people to get quiet, we've lost some time, so I'm sorry, the other class is going to get to play the review game for at least probably 20 to 30 minutes. But the pace that we've moved at, we just don't have time. So in the future, if you want time to be able to play those review games and stuff, we gotta get here on time. We gotta start class on time. And you gotta pay attention to be with me. You can't be talking to your friends, you can't be wasting time. Like these 45 minutes, I need it. So in the future, if we can move through the material quicker, we can probably play the review game. But your test next week, I'm just gonna show it to you. So you know what you're going to be expected to do.
Somebody get out of here, bro.
No.
Figure out all the problems in
But no, because...
And it wouldn't matter because, actually, that wouldn't even hurt because if you went over the weekend and learned how to solve all those problems, you'd still have to remember